Tell me how to draw the first quantity here. We take x, what do we do? We stretch, right? So let's say this is minus pi, 2 pi, and so on. When we stretch, what is 3 pi with 4 map to? 3 pi with 2. It's right here. Okay, so we have this. This value is 1/2, right? Scale 1/2. Is that clear? We stretch out a factor of 2. 3 pi with 4, go to 3 pi with 2. How do I draw this? Shift by pi. Is that true? Shift by pi. So thing is shift by 2 pi. I think it's shift by pi. How do I recognize the shifting quantity? Look at omega, and I see what is omega be replaced to? Replaced with omega replaced by omega minus 2 pi. So 2 pi shift by 2 pi, not pi. Okay, that's why we rewrite this in terms of that. So we won't make a mistake of shifting by pi. Okay, so we're taking this, which is x of e to the j omega over 2. We shift the whole quantity by 2 pi. So we have the 2 pi to 0 to 2 pi, right? We have it is periodic, so we'll do like that. So this yellow curve here is x e to the j is this quantity. And what's y? Y is the sum of these two. So let me draw the sum of these two. Okay? So it's very clear that from 0 to pi, there's no overlap. So it's okay in here. Oh, I'm wrong. Where is this going to go to? It's wrong. It goes to it's right here, right? Because this is 2 pi over 2. Okay, so if it's 2 pi, it's like 5 over 2. Sorry for this. Right? Okay. So from 0 to pi over 2, there's no overlap. So it's going to be like this. What happened from pi over 2 to 3 pi over 2? Be a straight line, right? If you add 2 straight lines, you get a straight line. Okay, and you know the ending of the straight line. Okay, so the end, it starts here, and end right there. Okay, so be like that, and so on. So the red curve is y. So given y, can I recover x? In this case, no. So this is okay when you have aliasing. That is the aliasing component. Similar to sampling. Okay? So we see that when, for certain case of x, when they're overlapping, we cannot reconstruct. So what is the condition of x? Such that there's no overlap. There's no aliasing. When it's shifting, this guy, there's not overlap. Do I stretch this out? Or do I compress it? To what? 2 pi over 2, right? This is pi over, go to pi over 2. This goes to pi. And shifting by pi will overlap. Okay? So to summarize, you have band limited to pi over 2, and it's okay. If x band limited to pi over 2, and when we downsample, pi over 2 is back to pi, right? And shift by 2 pi, it's okay. No overlap. Yellow. Okay, this is x, right? That's x, e to the j omega over 2. This is x, e to the j omega minus 2 pi over 2. There's no overlap, so it's okay. So this is the case where no aliasing, and it's invertible. Is that clear? Any question on this derivation? All right. Let's see. Tell me, when can we downsample? I have no error. So it is. When benefit to power 2, tell me in the time domain, what does it mean when you have a signal? Benefit to power 2 in the time domain.
I think that every odd sample must be zeros. So the this and the band limit to minus pi over 2 and pi over 2.
If every odd sample is 0, then you have the imaging problem. So it's not benefit to power 2. Now this is go back to sampling theorem, okay? Well, suppose you work for me, right? I'm your boss, okay? And you come in and say that, sir, you know, this is my spectrum. Is this a good way to sample? Is this wasteful? What do you waste? You waste the spectrum from pi over 2 to pi. This is unused spectrum. If you give me this particular signal with this spectrum, I'm saying that you're not sampling correctly. You're not doing critical sampling. Why? What does critical sampling mean? It means that you have to utilize the whole spectrum. Right? Use the whole spectrum. Right? What does use the whole spectrum means? It means that you have to use from minus pi to pi. This is wasteful. This is oversampling. You guys remember sampling theorem? It's like clear that this is oversampled. This means that you're sampling too fast. You're not using the whole spectrum. Right? This is sampling by oversampling by 2.